Nature of the roots of quadratic equations. So there are four cases in identifying the nature of the roots. So case number 1, when your d is equals to 0, you will be getting real, rational, and equal roots. Case 2, when your d is greater than 0 and a perfect square, you will be getting roots like real, rational, and equal. In case 3, when your d is greater than 0 and not a perfect square, the roots would be real, irrational, and equal. In case 4, when your d is less than 0, there are no real roots or your roots are imaginary. So these are the four cases. Okay? What does the D represent in the four cases? Okay? So the D here is called your discriminant. Alright? And the formula in solving your D or your discriminant would be D is equals to B squared minus 4AC. Alright, so as you can see here, this formula B squared minus 4AC came from your quadratic formula. Yan. So, yan yung naka-radical sign in your quadratic formula. And remember, in solving the discriminant and identifying the nature of the roots, we have to follow these 4 steps. So step 1, your equation should be in standard form. So meaning, when you say standard form, it should be in the form ax squared plus bx plus c equals to 0. Step 2, you need to identify values of a, b, and c. And again, a could be found in your quadratic term, b could be found in your linear term, and c could be found in your constant term. And remember, when we are getting the values of a, b, and c, it should be number only. Step 3, substitute the values in the discriminant formula. And again, our discriminant formula is D is equals to B squared minus 4AC. And step 4, you will be identifying the case. Okay, so you will be choosing from case 1, case 2, case 3, or case 4, depending on the result of your discriminant. So let me show you examples on how we are going to identify the nature of the roots using the discriminant. Okay, so example 1, we have here the equation x squared plus 6x plus 9 equals to 0. So what we are going to do is to determine the nature of the roots of the following equations using the discriminant. As you can see here, you just need to follow the 4 steps. Okay? So step 1, your equation should be in standard form. And upon checking, the given equation is already on its standard form. Step 2, identify values of a, b, and c. So in here, we have our a as 1 from your quadratic term. Our b is 6 from your linear term. And c is 9 from your constant term. And then step 3, substitute the values in the discriminant formula. So, We have here the discriminant formula. D is equals to b squared minus 4ac. Then just plug in or replace the variables with the given values. Our b is 6, so we have here 6 squared minus 4 times 1 for A and 9 for C. Then simplify. 6 squared equals to 36. 4 times 1 times 9, that is also 36. So the value of D is equals to 0. And this value falls on case 1, where D is equals to 0. Meaning the roots that we will be getting if we will be solving this equation would be real, rational, and equal. Second example. So we have here the equation x squared plus 9x plus 20 equals to 0. So again, we just have to follow the 4 steps in solving this equation. Okay, step 1, standard form. Okay, so it's already in standard form. Step 2, identify values of a, b, and c. So we have a equals to 1 from quadratic term, b equals to 9 from your linear term, c equals to 20 from your constant term. And step 3, use the discriminant formula, b squared minus 4ac. Then just substitute the values. B is 9, then squared minus 4 times 1 for A and 20 for C. And simplifying, that would be 81 minus 80. And your discriminant is equals to 1. And upon checking here, 1 is greater than 0 and also a perfect square number. So that will fall on case 2. And for case 2, the nature of the roots would be real, rational, and unequal. Example number 3. So we have the given equation 3x squared minus 5x equals to negative 4. So again, just follow the 4 steps. Step 1, your equation should be in standard form. So as you can see here, the given equation is not yet on its standard form. So you have to write it first in standard form. And that will become 3x squared minus 5x plus 4 equals to 0. Then identify again the values of a, b, and c. So a here is a 3 from your quadratic term, 3x squared. B is negative 5 from your linear term, minus 5x. And C is equals to 4 from your constant term. And step 3, substitute the values in the discriminant formula. So again, B is equals to B squared minus 4AC for our discriminant. And by replacing or by substituting, so we have here b squared will become negative 5 squared minus 4 times a, which is 3, and c, which is 4. And then just simplify. So negative 5 squared will give you an answer of positive 25. And 4 times 3 times 4, that will be minus 48. And by simplifying, our d here is equals to negative 13. And where does this number fall on the 4 cases? Okay, so it will fall on case number 4, which states that when d is less than 0, no real roots or imaginary. Okay, why case number 4? Because we have here a negative answer. And a negative number is always less than 0. That's why we got case number 4.